All right, last session for the night. We are going to go over best practices for Amazon EC2. So hopefully by now you've had a chance to create at least one instance. I think I created like 12 in the last hour. So yeah, let's take a look at the best practices. So to get the maximum benefit, you want to focus on security, storage, resource management, backup and recovery, and networking. So let's get into this. Security. Manage access to AWS resources and APIs using identity federation, IAM users, and IAM roles. So we haven't covered IAM yet, but I'll just go over this really quickly. So an IAM user would be like if you're in the console and you created your root account and then it said, hey, don't use your root account to log in, create an IAM user, that would be the user that you logged in with. You also probably saw some roles. Now, my user, I actually didn't give him IAM permissions, so you can't see it from here, but a role is a collection of security policies that allow your IAM user to access different AWS resources. So that's all a role is it's basically like a collection of security permissions, or what they call policies, which, if you're taking the exam, is in JSON format. So identity federation is different. So federation is when you use an external provider to authenticate your identity. So if you use Facebook, for example, or Google, you might sign up for a LinkedIn account, or you might sign up for an Amazon.com account because you want to watch Prime Video or whatever, and it'll ask you to enter, to create an account. And instead of going through the process of creating an account, it'd be like, hey, wouldn't it be convenient if you could just click on Google or Facebook and it will use your credentials to log in? Well, that is federation. So common federation patterns in Amazon would be Active Directory. So if you want to provide a single sign-on, you could do something where somebody logs into their AD account on their laptop, on their Windows laptop, and that user credential creates a token, which then is passed to a different software as that person uses their computer. And so they only really need to enter their password once, and that's when they log into their computer. From there, you can use Active Directory to federate into Amazon EC2 in order to log in. So that's a more complicated process. I'm not going to explain how that works, but if you can set up your IAM user with IAM role, practicing least privilege, that's what you want to do. So the second part here, establish credential management policies. So that'd be like your password policy that you set up when you create your account, and procedures for creating, distributing, rotating, and revoking AWS credentials. So this would be like if somebody leaves the company, what's the policy? It should be automatic, but there should be something that kicks off that automatically removes that person, revokes their AWS credentials. For creating credentials, HR's onboarding process, you should have a process that automatically creates a credential. If that person works in HR, then the role, they might have a department role where everybody in HR gets that same permission, that same role with security policies, or maybe it's by job function. So if they're a developer, it doesn't really matter what department they work in, they have a developer role, something like that. Distributing, how do you distribute this? How do they get their password? How do they get their access key ID? How do they get their secret access key? And then rotating, how often do they have to change their password? How often do you rotate your keys? How often do you change the method of authentication, not the method, but like the password basically, or your key, so that they don't have the same key forever. There's an automated way to do that that's extremely convenient for the user. So best practice would be don't use the same password for 5 years. Don't use the same key for 5 years. Have an automatic way of creating things so people have access to the resources they need when they need them. And make sure you revoke credentials when appropriate. And it's not always a bad thing. Like somebody leaving the company, it could be that somebody gets a promotion and you need to revoke their role and assign a new role. Maybe they moved to a different department. They went from finance to marketing, or whatever. and distributing as well. So when you're distributing things, don't be sending stuff via plain text. You know, find a more secure way. If you do need to send a password in an email that's automated, maybe encrypt it. You know, do something. So for more information, you can go to IAM Best Practices. I'm not covering identity and access management right now. We're just doing EC2, so we'll get into that later. Second line is security. Implement the least permissive rule. We just talked about that. Regularly patch, update, and secure the operating system. Well, duh. Okay, so if you're going to create an instance, patch it. Don't be one of those people that gets a 0-day attack or WannaCry or whatever else. If you want information on patching, you can see managing software on Linux. It's pretty simple, folks, and it's very easily automated. If you don't patch your systems, then it's just sheer laziness. So that's best practice. Moving on to storage. Understand the implications of root device type for data persistence, backup, and recovery. So root device types. We know of two, right? We know of EBS-backed volumes, and we know of instance store. So what's the difference with data persistence? What's the difference in how you back it up? Does it go to EBS? Does it go to S3? How do you recover it? How do you recover something from S3? What data is going to be there? How do you recover something from EBS? Do you actually recover it, or are you just building a new server? So it's good to go back and review some things about root device types, which is why I made a whole video on root device volumes to understand what your options are and how you store the root device type. Okay, so and then the separate EBS volumes for operating systems versus your data. I talked about having a root device volume for your operating system and then a separate 25 gig device for your cat GIFs. Ensure the volume of your data persists after instance termination, whether you're doing it with the CLI or with PowerShell or with infrastructure as code tool, or you're doing it in the GUI. Make sure, like in the GUI, for example, is the way we did it, that box is unchecked. Do not delete on termination. That way, if you do delete it or it gets accidentally deleted and you have data on there, you're not losing all of your data. You might lose the instance, but you can just spin up another instance with the same AMI, attach the volume, and you're good to go. If you use instance store for database storage, ensure you have a cluster with replication factor that ensures fault tolerance. Why would you do that? Well, because if something happens to your instance and you're using an instance store, guess what happens to your data? Kaput, it goes goodbye. Always encrypt your disks and your snapshots. Okay. Resource management, using instance metadata. What do we call that? Tags and custom resource tags to track and identify your resources. You can get more information on tags, how to use them. There's some pretty cool uses for tags, but like I said, mostly it's finance and kind of utilization type of things. And scripting. If you're doing development, it's super handy to have stuff tagged consistently. And the last one there for resource management, view your current limits on Amazon EC2. Plan to request any limit increases in advance. So that might be like APIs, for example, or how many EBS volumes you can have in a region, or how many instances you can have in a region. So that way, if you need something, you need to scale something out, whatever, that you have all the time you need, because there's lead time on some of those things. So you want to make sure you're not doing it like when prod is down. All right, and backups and recovery. Regularly back up your volumes. There's an option to do that. You can create snapshots. You can create an AMI from your instance to save the config as a template. Should you have some kind of launch failure, you want to deploy your critical components across multiple AZ, replicate your data appropriately. Why? Well, if an availability zone goes down and you're using multi-AZ configuration, then you're going to have another availability zone where your application will be available there. And if you're replicating data appropriately, all of your data should be there. Design your applications to handle dynamic IP addressing when your instance restarts. So, maybe look at how do you do that? How do you use dynamic IP addressing when your instance restarts? Well, if you have IPs hard coded into your application to look for an instance that doesn't exist, that's not going to help you. But you can use things like elastic IPs and load balancers and things like that to get a static endpoint and then just have dynamic resources underneath that endpoint. Monitor and respond to events. monitoring Amazon EC2, it's probably going to be in CloudWatch. We're not covering that, but just know that you should have monitoring set up. Don't deploy stuff without having visibility into it. Ensure you're prepared to handle failover. You should practice this, okay? I can't remember the name of it. It's like some kind of controlled crisis. Anyways, they call it something where you just mess with stuff all the time. But for a basic solution, you can manually attach a NIC or elastic IP to a replacement instance. For an automated solution, you can use auto scaling. You know, if your traffic, maybe it's a traffic-based rule where you have a certain amount of traffic, then once it exceeds that threshold, it creates another EC2 instance, and then it load balances the traffic for you. And then when the network traffic per unit of time is below the threshold, then that instance is terminated, and then you go back to having one. Regularly test the process of recovering your instances. This is huge. I've been in companies where we have backups, hopefully, and people don't know how to do restore. They don't know how to do a failover. They don't know how to do DR. They don't know how to do, like, what happens if your volume fails? How do you recover that? How do you restore data? You need the data, and how what is the point in time you can go back to? These are questions your customers are going to have, and you have to have answers. So always have backups, always have a recovery process. Even if it's automated, document it. Make sure it's documented, and make sure that you do training so that everybody knows how to do it. So you should have regular sessions, even if it's just like once a quarter, once every 6 months, just refresher training to go, hey, we're going to do a failover test of this application, and just rotate through all the different parts of components of your architecture to make sure you're designing not just scalable, but resilient architecture that can withstand an availability zone going down, or with an EBS volume going down, or an EC2 instance going down, having problems with your operating system. Treat your servers like cattle. I would much rather spin up an instance and take something out of a load balancing group and then troubleshoot it later after I've fixed the production issue than sit in there. And I've seen this for days. I don't know, days, people just looking at every possible Stack Overflow article under the sun, trying to figure out why their Linux machine's not working properly or won't boot because somebody commented out the /root or the FS tab or something like that. So yeah, testing is key, training is key, documentation more key. And then lastly is networking. You have a TTL value, which is a time to live for your applications to 255 for IPv4 and IPv6. If you use a smaller value, there's a risk that TTL will expire while application traffic is in transit, causing reachability issues for your instance. What does that mean? So you got to talk bits, right? So you got 256 and counting 0. So TTL is how long your application might leave a connection open, for example. And it could be how long data stays in a Redis cache. It could be whatever. But with networking for TTL, if your TTLs are too low, then you run the risk that that will expire and that traffic in transit, and then you might have issues getting to the instance. So if latency becomes an issue, you have a slowness on your application, which causes congestion, and then you have a backup of traffic because they're all synchronously waiting to go into a queue, for example, and you're not using SQS. Well, then your TTL is going to rise, and if your threshold for TTL is too low, then you might start having failures where people are like, hey, is this service down? So set your TTL to 255. Okay, so there's your overview of some very simple, basic best practice on EC2. Hopefully that helps you out. So when you're building your instances from now on, try to go through these best practice guide and see if you can, for example, go create an instance again, and but this time try to encrypt the volume. It's a simple step, but adding those things makes a big difference. And don't just use the GUI. Try to do it from AWS CLI. You do it from PowerShell. I highly recommend AWS CLI. PowerShell is not used nearly enough, or nearly as much as the CLI, but you can start saving these scripts. So heck, put it in your PowerShell profile, put it in your Bash profile, and create like an alias for it, and you can just spin up an EC2 instance real quick, and sometimes you can do just like, imagine how cool it would be, for example, if you create an alias that had this huge long thing that was like, create an instance and encrypt the EBS volume and assign this and put it in this VPC, and it has to be in this subnet, and here's the IP address, and I'll have to be, and you have all this crap, and then at the end of it you just put it in your bash profile and you have test VM and you hit enter and it just goes and runs that command for you. Well, that would be nice. So when you're doing testing, sometimes little shortcuts are helpful. And then you can go back and just keep adding stuff like, oh, I didn't know I was supposed to encrypt this. I'm going to go ahead and encrypt that. Or, oh, how do you set a TTL to 255? Maybe I'll create a script that makes a VPC and, my application, somewhere in there in my application, I set the TTL to 255. So anyways, if you got any questions, let me know. And if not, that is the end of the introductory section of using EC2. And now what we're going to start to do is I'm going to go through the tutorials. So the tutorials section is basically what you find if you go online to Udemy or Linux Academy, A Cloud Guru. All they're doing is just doing this. So I'm going to do each one of these individually, and we'll go through them, except I'm not going to charge you for it because it's all free. It's right here on the Amazon documentation page. So have fun. I'm going to call it a night, and I'll probably hit this up a little bit tomorrow, and we'll start doing some web servers. All right? Take care.